This is Heejo from Pattern Recognition and Machine Laboratory of Korea University. From now on, I will present our paper, Pruning-Guided Curriculum Learning for Semi-Supervised Semantic Segmentation. Our paper is focused on the performance enhancement of semi-supervised semantic segmentation. Semi-supervised learning assumes that only a fraction of the entire dataset is labeled. So the key challenge of it is to leverage the unlabeled dataset effectively for network training. Pseudo-labeling is a typical solution for semi-supervised learning to train the unlabeled dataset. It assigns the most probable class of predictions for a labeled sample as slow-ground truth. Studies that utilize labeling exploit the confidence threshold strategy to reduce the influence of wrong predictions. However, even though the predictions are erroneous, many highly confident samples exist, and they cannot be filtered out by confidence thresholding. This phenomenon is especially stronger in the early learning stages. It significantly suppresses the effect of self-training that utilize unlabeled dataset. To mitigate this limitation, our paper leveraged the network pruning. Our idea is based on the recent study that discussed what deep neural networks forget through pruning. The study showed that pruning severely impairs DNS generalization and memorization ability on insufficiently trained samples. Inspired by this finding, our study applied pruning as a practical tool to identify the samples that are not yet well trained in the current stage. We named our proposed method as Pruning-Guided Curriculum Learning, called PGCL. First, we construct a teacher-student framework following the previous work, MinTeacher, which is a representative method for semi-supervised learning. The difference between MinTeacher and PGCL is a pruned teacher by applying the pruning to the teacher network. Leveraging the obtained pruned teacher, we propose a novel confidence score deployment strategy for pseudo-labels enhancement. Inspired by recent finding, which I mentioned above, the more consistent samples before and after pruning, it can be considered that these samples have been better trained in the current stage. Therefore, the higher similarity between the two outputs, the higher confidence score is assigned. Then, in the same way as the existing pseudo-labeling method, only samples exceeding the predefined threshold are used for semi-supervised learning. Additionally, we exploit a curriculum policy that addresses the strengths of network pruning. Unfortunately, there is a trade-off between noisy samples and hard samples. If the influence of pruning on the score function is too high, learning of hard samples is also suppressed. Therefore, as the learning progresses, the influence of pruning is gradually reduced so that the learning of hard samples can be sufficiently taken. To demonstrate the superiority of our proposed method, we conducted an experiment by applying it to both pixelized consistency loss and pixelized contrast loss. The formulation of loss functions are as follows. The experimental results of the proposed method are as follows. Following the previous works for semi-supervised semantic segmentation, Pascal VOC and Cityscape dataset are used. In conclusion, the proposed PGCL framework achieved state-of-the-art performance on Pascal VOC 2012 and Cityscape dataset. In particular, PGCL shows the superiority performance compared to the error localized network called ELN, similar to our approach in that it refines noisy labels. The qualitative results of the proposed method as follows. At first, we evaluated how well the labels are defined. The visualization shows the prediction extracted from the training model at the early learning stage. As you can see, while confidence thresholding incorporates the erroneous samples into training, our method filters out noisy samples well enough. This figure shows the results of comparing the prediction mask with the state-of-the-art method. As can be seen, it demonstrates that the proposed method shows the best results. This is the end of my presentation. Thank you for listening.